Today, we're going to be talking about gravity and also the difference between mass and weight. Okay, so there's many types of forces in the universe. Okay, forces are the things that can make things move. Okay, so we've got gravity that keeps us down on the earth, that keeps the moon revolving around the earth. Okay, we've got magnetism, which is the attraction of things made of like iron and steel to a magnet. We've got friction, the force that slows things down. Okay, all of these things can cause things to move or slow down in some way. So, unbalanced forces cause motion. So, this is the deal. If we have more force on one side than on the other, we're going to have motion. Okay, I had more force over here. If I apply more force over here, we're going to go that way because there's more force on this side. It's an unbalanced force. That's what causes motion. Now, if we have balanced forces where it's pushing together with the same force, no matter how hard I push, nothing's going to go anywhere because I'm pushing the same with both sides. So, balanced forces do not cause motion. Unbalanced forces cause motion. Okay, gravity is a force that all objects have on each other. So the more massive an object is, the more gravity it has. So the force of gravity attracts objects to each other. So right here, the moon is being attracted to the earth because the earth has more gravity than the moon. Okay, the strength of gravity is related to the mass of an object. So things with more mass have more gravity than things with less mass. So, for example, right here, this could represent the Earth, this could represent the moon. The Earth would have more mass than the moon. Or also, we could think the sun is a lot more massive than the Earth. So the sun has more mass than the Earth. So the sun's gravity is a whole lot more than that of the Earth. Okay, the sun's enormous mass keeps the planets and other objects in the solar system revolving around it. So the reason that all of the planets go around the sun, that they orbit the sun, is that the sun is so massive, it has a whole lot of gravity. It has more gravity than all of the planets and all of the moons. Okay, the Earth's gravity exerts a force down towards the center of the Earth. So that's lucky for us because, if we didn't have that, we'd fly off into space. So the Earth's gravity keeps us down on the Earth. It pulls us to the center of the Earth. Okay, Earth's gravity holds the planet together and keeps everything, including you, from floating off into space. Okay, the farther an object is away from the center of the Earth, the less Earth's gravity affects it. So, the farther you get away from Earth, the less the gravity of Earth affects it. So, when we get outside of the Earth's atmosphere into space, Earth's gravity doesn't affect you at all if you get further enough away. So, like this space station right here, Earth's gravity is affecting it some because the space station is revolving around the Earth, but there's a whole lot less gravity out there. And the farther you get away, the less gravity there would be from the Earth. Okay, in the space around the Earth, gravity holds satellites in orbit, including the moon. So that's why the moon stays in orbit around the Earth because of the gravity of the Earth. Okay, the moon is much smaller than Earth, so it has much less gravitational pull towards its center. However, the moon's gravity exerts a force on Earth's oceans to create tides. So the moon does have gravity. It's just less than that of Earth. And the moon its gravitational force pulls the water of Earth towards it, and that's what causes the tides. Okay, weight is a term commonly used to describe how much gravity is being applied to a particular object. Okay, so mass is how much stuff an object has in it. Okay, and weight is determined by how much gravity is pulling down on an object. Okay, we use a spring scale to measure an object's weight on the Earth. So you could use a spring scale, or you could use one of the scales that you stand on that also measures weight, but it's measuring the pull of gravity. It's what it's measuring. Now, okay, let's go on here. We're measuring the force of gravity pulling that object down towards Earth's center. That's what weight is. It's according to the pull of gravity. Okay, you experience a greater gravitational pull on the Earth than on the moon, so you would weigh more on Earth than you would on the moon. So the Earth is about 4 times bigger than the moon, so you would weigh about 4 times more on the Earth than you would on the moon, because the Earth has 4 times as much gravity as the moon does. Now, the moon still has gravity, it just has less gravity. Okay, on the moon, you could jump up about 2 meters into the air. Pretty cool. Okay, gravity is a constant force that pulls on all objects equally. Okay. Without air resistance, gravity would pull all objects to the ground at the same speed. So when you drop a rock and a piece of paper, the only reason they don't hit the ground at the same time is because the air resistance. Okay, because the piece of paper catches more air than the rock does. So if we removed all the air, okay, they would fall at the same speed. And, scientists have done this experiment in a vacuum where they removed all the air, and that's exactly what happens. The rock and the piece of paper hit the ground at the same time. Pretty cool. We'll watch something like that on YouTube at some point. Okay, air resistance causes friction, which slows down some objects. Okay, so the piece of paper had more friction with the air, so it slowed down. Now the rock didn't have much resistance at all, so it hit the ground first. Okay, this is why a sheet of paper takes more time to hit the ground than a stone dropped from the same height. Okay, gravity is a powerful force, but it can be overcome. The magnetic force between a paperclip and a magnet is stronger than the force of gravity on the paperclip. So the reason that the paperclip is hanging, it hangs straight down from the desk, is because of gravity. Okay, but the force of this magnet, when we get it close enough, is going to be stronger, so it's going to pull towards the magnet like this. Okay, magnetism overcomes gravity and allows the magnet to lift the paperclip. I think we'll do pretty much this exact thing in class at some point. Okay, huge airplanes use force and lift to overcome gravity and fly into the air. Okay, what causes motion? Now remember, when one side is pushing more than the other side, when there's more force on one side than the other, it causes movement or motion. So that would be an unbalanced force causes motion. Now remember, balanced forces, you won't have any motion. Okay, what tool can be used to measure the force of gravity on an object? Remember, let's see. What this is doing is measuring the weight of an object. So we would use a spring scale or the kind of scale you stand on. Okay, which force holds Earth's atmosphere in place? So let's think. Magnetism? No. Solar energy? That's just goofy. Friction, no. This is what we've been talking about in this slideshow. Gravity holds the atmosphere of Earth in place. Okay, now remember, so let's see, weight has to do with the pull of gravity on an object, and mass has to do with how much materials in the object. Okay, it's how much stuff is inside as mass. And we measure mass with a triple beam balance, and we can measure weight with a spring scale or a scale you stand on. Okay, so that was gravity.